Step Talks Education. Let us continue with our ionic chemistry and qualitative analysis, and we look at the detection of cations. In this case, we have already seen the two major reagents used for detecting cations, that's sodium hydroxide solution and then ammonia solution, and we have exhaustively had a look at them. So now let us try to zero on some cations and we see how we can confirm them. That is it. Confirmatory tests for cations. So we have some few cations with some few confirmatory tests that they can bring in to confirm them, because they have some reagents and they make some observations which are not common to other cations. So we use those reagents and their observations as being their confirmatory tests. So let us, under this, look at the first one, that is the calcium ion. So we are going to look at the test and then we look at the equation for the reaction involved. Calcium ion. So for calcium ion, let us draw a simple table here for the test, the observation made, and then the deduction that we can get from that. So test, observation, and then the deduction. Remember, we are dealing with solutions in this case, so we are looking at solutions containing some of these cations here. Let us start with calcium ion. Now, for calcium ion, we can add a few drops of dilute sulfuric acid. You see, here the sulfuric acid will provide the sulfate ion, and that sulfate ion will combine with the calcium ion to form insoluble calcium sulfate, which will be formed as a white precipitate. So we need mainly a solution that will provide us with the sulfate ion that should combine with the calcium ion to form a white precipitate of calcium sulfate. So that's what I'm saying, or any solution of a soluble sulfate salt, or any solution with soluble sulfate salt. So we can have, say, copper 2 sulfate solution, or it can be potassium sulfate solution, or it can be sodium sulfate solution. And in this case, you must know that the salt, the soluble sulfate salt, whose solution we shall use, will be chosen depending on its availability and price. If it is readily available and it is having a low price, or it is cheap, then we can use it in this case for testing for calcium ion, instead of using dilute sulfuric acid, because either dilute sulfuric acid that we have used or the soluble sulfate salt, its solution, they will play the same role of providing the sulfate ion that will have to combine with the calcium ion to form what we call calcium sulfate, which is formed as a white precipitate. A white precipitate. So our deduction will be calcium ion in this case. So that's what shall be our deduction. We shall be having calcium ion. Remember, magnesium ion cannot give us this, reason being magnesium ion will have to combine with the sulfate ion provided by either the dilute sulfuric acid or the solution of the soluble sulfate salt. But the magnesium sulfate formed is a soluble sulfate salt, so it will not be able to be precipitated. So for that reason, we use this one here to confirm calcium ion in this case, or it will help us to distinguish between calcium ion and magnesium ion as well. So let us try to see the reaction equation here. So the reaction equation, we said that the calcium ion, which is in the solution under test, will have to combine with the sulfate ion provided by either the dilute sulfuric acid, whose drops you are adding, or the solution of the soluble sulfate salt, and we shall be able to get a precipitate of calcium sulfate. So it will be precipitated. It will be formed as a solid. You get a white precipitate of calcium sulfate. And that makes us to deduce that there is calcium ion in the solution under test. So for zinc ion, we have already seen it. That is, we use ammonia solution. Aluminium ion, in this case, let us go ahead and we look at lead 2 ion. Lead 2 ion, which is capital P, small b, 2 plus. So for lead 2 ion, let us also try to draw the same table here. For test, observation, and then the deduction. Test, observation, and the deduction. So lead 2 ion. One of the tests that we can use in this case is, let me call this one here 1. Let me use this one here 1. We can say add a few drops of dilute sulfuric acid, or a few drops of a solution of a soluble sulfate salt. So as we have seen earlier on with calcium ion, this solution of the soluble sulfate salt or the dilute sulfuric acid still will give us the sulfate ion, or will provide the sulfate ion that will combine with the lead 2 ion to form insoluble lead 2 sulfate, which will be precipitated. So we get a white precipitate. We get a white precipitate, and our deduction is that we shall be having lead 2 ion in this case. So you don't have to forget this. So I would wish to write the equation for the reaction in this case under the observation. Allow me to write the equation for the reaction for the sake of your own consumption when you are revising. I will not write the equation outside the table. Let me write it here, although we don't write it here in exams. Unless otherwise it is asked for in a theory paper, then we write that equation. So the equation for the reaction here is the lead to iron, which is in the solution under test, will combine with the sulfate ion, which is in either the dilute sulfuric acid or in the solution of the soluble sulfate salt, and we get insoluble lead to sulfate. This is what we get. So it makes us to confirm, or it makes us to know that the substance whose solution we are dealing with in this case contains lead to iron. Then next is, we can also be asked to add a few drops of dilute hydrochloric acid or a solution of a soluble chloride salt and heat. Okay, let us see what takes place here. In this case, the dilute hydrochloric acid or the soluble solution of the soluble chloride salt will provide the chloride ion that combines with the lead to iron in this case to form a white precipitate. So you can see, in this case we get a white precipitate, but we can see from here that even the sulfuric acid, the dilute sulfuric acid, or a solution of a soluble sulfate salt still gives us a white precipitate. Now, we have the heating which comes in later. When you heat the white precipitate which is formed, it will dissolve. So we shall say soluble on heating, soluble on heating. And remember that when it cools down, the white precipitate will come back. So it is, it is able to reappear on cooling. It is able to reappear on cooling. I've added this one as an additional information. So the reaction here, in this case, the reaction is the lead to iron being a divalent cation, and then in this case the chloride ion having just only one negative charge. We shall have two of these chloride ions combined with the lead to iron, and we get lead to chloride. And this lead to chloride will be precipitated, but it is soluble on heating, and then when it cools down, the precipitate reappears. That means that it is having a high solubility at a high temperature and a low solubility at a low temperature. So still this one means that we have lead to iron here. And then finally we have the last test here, which is always frequently used, that we need to add a few drops of potassium iodide solution. And in most cases they ask a candidate to be able to carry out this test here without being given. So you must know that I have to use potassium iodide solution if I want to confirm the presence of lead to iron. And in this case we get a yellow precipitate. A yellow precipitate. And then our reaction equation is the lead to iron, which combines with the two iodide ions of the potassium iodide, and we get a yellow precipitate of lead to iodide. And this one means that we have lead to iron and it has been confirmed. So These are just but only 2 cations. We shall still go ahead and we see other cations. Tep Talks Education. Thank you for watching.